Welcome everybody to another session of AMS. So in this session, I'm going to brief you how we can create periodic structures in this interface. Before going into that, I have to give you an outline about what is actually this band module. So in this module, it will help you to excel in simulating complex material systems such as nanomaterials, polymers, catalysts, and crystalline solids. Its flexibility allows for multi-scaling modeling, combining quantum mechanical precision with molecular or coarse-grained descriptions for larger systems. So periodic systems refers to materials with repeating structural pattern that extend infinitely in 1, 2, or 3 dimensions, enabling their unique physical and chemical properties. So these systems are broadly categorized into one-dimensional, two-dimensional, and three-dimensional periodic systems. One-dimensional systems such as nanowires, polymers, then two-dimensional systems like graphene, and three-dimensional systems like bulk frameworks or crystals, for example, metal organic frameworks. So it possesses periodicity in all the three dimensions. So these classifications helps in understanding and modeling the material's behavior in diverse scientific and technological context. So let me introduce to you how we can perform or how we can design periodic structures in this interface. So this is actually the band GUI. You can see it is quite different from the ADF GUI. At the bottom we can see the structure tool, then the slice tool for generating slab models, then this periodic display, and also how we can switch between different uh, components. So let me show you how we can generate a crystal structure from database or from this structure tool. So in the structure tool, you can see that there is cubic, hexagonal, monoclinic, orthorhombic, tetragonal, triclinic, and various crystal structure categories. And from here, I am just selecting one NaCl structure from cubic packing, and you can see a small dialog window which analyzes some default parameters, lattice parameters, and basis vectors. Just I'm clicking on this OK, and it will display one more pop-up window with confirming the unit cell. So it will generate one crystal structure of NaCl. So this is actually how we can generate a structure from structure tool. Like the same, we can generate it from database. So database, as I have explained in that previous ADF package, so we can select any crystal structure. So I'm just selecting the same NaCl. So you can see the molecular systems and crystal surfaces. So this is actually from database. So you can see that it is taking some time to generate that crystal structure. So once it is finished, it will display the pure crystal lattice. So you can see that NaCl structure. At the same time, I'm just showing you another form crystal structure from structure tool. Just I'm going to select a tetragonal structure till. So it is showing the dialog window covering some basis parameters, basis vectors, and lattice parameters. And just for the information, I'm just clicking it OK. We will discuss in brief about all these parameters in later sessions. So how we can build a crystal. So this is actually a rotile structure from crystal 2. Like the same, we can select from our database also. So now I will show you how we can create a polymer structure. So as I told in the beginning that how we can form a builder tool. So here in edit menu, just click on this builder of polymer. So I'm just selecting polymer tool. So just select the monomer unit, for example, the simple styrene monomer unit I'm just selecting for a demo. It's taking some time. After that, you can see how it is visualizing in this interface. Yes. So you can see two linker atoms, 1A and 1B. And I'm going to frame a monomer polymer units of 20 different monomers. It's the same static units. So click on generate. Oops, sorry. So click on generate. So now you can see that how that monomer unit has been developed with polymer. So actually it is a lengthy brief session. So right now I'm just winding up with these two examples. In the next session we will brief you how we can generate slab model, crystal models with bulk 2-dimensional, 3-dimensional systems.